stars, each of one solar mass, are approaching each other for a head-on collision. When they are at a distance of 10 to the power 9 kilometers, their speeds are negligible. What is the speed with which they collide? The radius of each star is given 10 to the power 4 kilometers. So let's say this is the initial state in which they are at a distance of 10 to the power 9 kilometers. The distance between the center of masses of both the stars is 10 to the power 9 kilometers, and this is 10 to the power 12 meters. Let's say this is the state 1, which is the initial state, and in the final state, which is state 2, this is just before the collision. They come tangential to each other, and the distance between the two center of masses will be equal to 2 times the radius, and the radius is given 10 to the power 4. So the distance between the two centers is going to be 2 into 10 to the power 7 meters. The total energy in the state 1 should be equal to the total energy in state 2. So if we look at state 1, the kinetic energy is 0 as it is given the speeds are negligible, and the potential energy is minus g mm by 2r, is minus g mm by r, where r is the distance between the center of masses and here it is d. So this is minus gm squared by d. Both the total energy and the potential energy will be equal because the kinetic energy is 0. So this value minus gm squared by d will also be the total energy in state 1. And if we look at state 2, the potential energy is going to be minus gm squared by 2r, and the kinetic energy will be equal to the sum of kinetic energy of both the bodies. As both are identical stars, both the stars will also possess the same velocity. So the kinetic energy is going to be 2 times the kinetic energy possessed by each star, which is half mv square. So this is mv square. So from conserving the energy, minus gm squared by d should be equal to minus gm squared by 2r plus mv squared. From this we get the value of v to be equal to gm by 2r minus gm by d under root. All the values g, m, r and d are known to us. So let's substitute the values. We get the velocity to be equal to under root 6.6 into 10 to the power minus 11 into mass of the star, which is given to be 2 into 10 to the power 30 times 1 by 2 into 10 to the power 7 minus 1 by d, and d is 10 to the power 12 meters. If we compare these two terms, we see 10 to the power minus 12 is very small as compared to 1 by 2 into 10 to the power 7. So for this case, we neglect this term and write v to be equal to square root of 13.2 into 10 to the power 19 by 2 into 10 to the power 7. So this comes out to be 2.57 into 10 to the power 6 meter per second. So this is the velocity by which both the stars are going to collide.